chemical properties of carbon compounds. See, so many chemical properties are there. Here we are going to discuss the four types of the chemical reaction. That is, the first one is the combustion reaction, the second one is the oxidation reaction, third one is the addition reaction, and fourth one is the substitution reaction. See that we already studied that combustion reaction in lower class. See, the combustion reaction means there is the carbon in on allotropes form. That is, that it burns in oxygen to give the carbon dioxide, and along with the release of heat and light. So that means carbon usually react with oxygen and heating to give large amount of heat and light. So and also carbon dioxide gas is produced. First, the combustion reaction example. Some of the examples are given here. Carbon react with oxygen and undergoes combustion reaction to produce carbon dioxide, heat and light. Then methane, hydrocarbon. So methane react with oxygen and undergoes a combustion reaction to form a carbon dioxide, again heat and light. Then third, ethanol or ethyl alcohol react with oxygen and undergoes a combustion reaction to produce carbon dioxide, water and heat and light. So these are the combustion reaction example. Here some saturated and unsaturated hydrocarbon already were studied, that is saturated and unsaturated hydrocarbon. Generally the saturated hydrocarbons gives, that is a flame is clean, and the unsaturated hydrocarbons, that is in yellow flame, that is in shooty flame, that is a lots of the black smoke. For example, the saturated in home LPG cylinder, LPG gases. See, LPG gases gives what, that blue color, bluish flame. Then unsaturated example for candlelight or any woods burning. So it gives what, black smoke. Some activities are there. Suppose if you take the carbon compound like naphthalene, camphor or alcohol, whatever it is, just take a take in spatula and observe the flame. Suppose if you do in that flame, that is the observe the nature of the flame and note whether the smoke is produced, what is the color of the smoke, and place a metal plate above the flame using of this alcohol, naphthalene and camphor. See, the place of metal, it's produce black color smoke, that will be become unsaturated compound. The saturated compounds like only the ethanol. The ethanol gives here it gives LPG, like liquefied petroleum gas. So many compounds are methane or whatever it is. Just in flame, burning in flame, what happens? It gives so that is clean flame. That is it gives a sooty flame. Okay, this can do in our laboratory. That is for example in our laboratory lighting, the Bunsen burner that adjacent in airfoil. What happened? Sometimes that base in that fold, that Bunsen burner having that base in that fold, some suppose if you do then some adjustment in that fold, what happened? It gives yellow flame. That is incombustion of that fuel. When incombustion of the fuel means, that is black color in smokes produces, large number of black color smokes are produced. Combustion flames usually they gives blue in color flames. Already you have learned that oxidation, that addition of oxygen, that definition. Here that the carbon compounds can easily oxidize on combustion. That is, in addition of this complete oxidation, we have the reaction which is alcohol converts to the carboxylic acid. For example, CH3, CH2, OH. This is ethanol. The ethanol, it undergoes the oxidation reaction in the presence of the alkaline K1O4, that's potassium permanganate. K1O4 means potassium permanganate. On heating, it's or acidic potassium dichromate. You can use either alkaline potassium permanganate or acidic potassium dichromate K2Cr2O7 and heat. You can use any one. Gives the carboxylic acid. The carboxylic acid is CH3COOH. This is called ethanoic acid or acetic acid. So this is the oxidation reaction. Examples of the oxidation reaction. See that here, that generally in inorganic reaction and organic reactions are differ here. That means you can see with the where it is the product is obtained from this to this means this having some mechanism step, then only the stepwise mechanism gives this product. Okay, generally you can write this, the general reaction like this, the mechanism also there, that mechanism you are going to learn in higher studies level, that is higher secondary level or in UG level. Then next is addition reaction. What is that? Addition reaction. That is the addition reaction. For example, unsaturated hydrocarbon. The unsaturated hydrocarbons means what? That is carbon-carbon double bond. And the hydrogen, in the presence of the catalyst like palladium, platinum or nickel, so that to give a saturated hydrocarbon. That means saturated means that is carbon-carbon single bond. The carbon-carbon double bond will become carbon-carbon single bond. See here, for example, we can write the carbon-carbon single bond R. Look, this is the unsaturated compound. Here the R indicates any alkyl or aryl group. This is the alkyl. Maybe for example you can write CH3 or CH3CH2, whatever it is. Just the R indicates any alkyl or aryl groups. It will become, see the C double bond C. It will become in the presence of nickel catalyst or palladium catalyst, in the presence of hydrogen, to produce hydrogen R. So this hydrogen goes to join. That is why addition of this compound. Already how many compounds are here? How many molecules? 1, 2, 3, 4. And the two that is one double bonds are present here. The double bonds converts to single bond. Just this hydrogen to joined here. So one hydrogen in this carbon atom and another one hydrogen this carbon atom. So it will become addition of this molecule to this compound. So that this is called addition reaction. So unsaturated to saturated hydrocarbons or saturated compounds, because carbon-carbon single bond, here carbon-carbon double bond. So this is the examples of the addition reaction. That is you have seen, that is that advertisements of stating that some vegetables are healthy, that that is animal fats are generally contain saturated fatty acids, like which are said to be the harmful for health. This that is oil containing, that is unsaturated fatty acid should be chosen for the cooking. Okay, so unsaturated means this. So we are using this unsaturated hydrocarbon for vegetable oil. Then substitution reaction. Here the substitution reaction, the saturated hydrocarbons are fairly unreactive and are inert in the presence of most reagents. Like however, in the presence of sunlight, what happens means the chlorine is added in hydrocarbon, the reaction will be very fast. That is, chlorine replaced by hydrogen atom by 1 or 2, that is 1 by 1. It is called a substitution reaction example. For example, here CH4 methane react with chlorine. So methane react with chlorine. What happens? See here, I can write here the reaction, the structural form. CH4 react with chlorine. First, replacement of one hydrogen atom and to join HCl, Cl to becomes what? HCl. Again, one more HCl also replaced. That means hydrogen is replaced by chlorine atom. So what happens? So CH2 Cl. Here the CH2, sorry, not CH2 Cl, first one is, sorry, first the hydrogen is replaced in the HCl. To what happens mean, this hydrogen HCl. So what happened? This Cl is joined here, so it will become CH3Cl and HCl. So this is the substitution reaction. What substituted means, one chlorine atom substituted here. The chlorine molecule, the two chlorine atom, one of the chlorine atoms to replace of one hydrogen atom, it will become CH3Cl, and the remaining one is it will go HCl. That's mean the remaining mean this hydrogen joined to this chlorine atom to form the HCl. So this is called a substitution reaction. Next is soap and detergents. Take two test tube. Suppose take two test tube, adding of water of 10 ml of water or 5 ml of water, whatever it is. Just take the test tube A and the test tube B. Label it test tube A and test tube B. Suppose 10 ml of water, adding of water in this test tube, both test tube in 10 ml water, and add some oils, that is in vegetable oils. You can add it in test tube A or B, whatever it is. Just adding of oil, drops of oil, okay, both test tube oil, and adding, that is here the test tube B, add some soap solution also, plus soap solution. What happens means, shake vigorously. Immediately adding of this two compounds, shake vigorously and leave it sometimes to undisturb the test tube. What happens? You can see oils does not dissolve in water. When the soap solution and water oil, look at this, they have some difference. This means you can check with this experiment in your home also, or you don't want to take any test tube, just in a transparent glass also you can take it. Just pour some water in both glass and put a dry oil droplets, and one of the beaker there is oil and soap solution. Observe it and tell what happens. You can see that. See that soaps are the soap molecules are, that is the sodium or potassium salts of the long chain carboxylic acid. That means they have the ionic end. That means soap interact with water while the carbon chain interacts with oil. Usually soaps interacts with water and the carbon chain interact with the water. So this is, look, this is a oil droplet. This is an oil droplet, okay, and these are called the sodium or potassium ion. So Na plus ion, all these are the Na plus ion, sodium ion. So here that ionic end, that is soap, interacts with water while the carbon chain interact with oil. So the soap molecule form a structures that is called micelle. This is the soap molecules are called, that is micelle forms, that is formations of micelle, where one end of the molecules is towards the oil droplet, and that another end, that is the ionic end, that is face outside. So this forms an emulsions in water, so that the soap is micelle that helps to pulling out the dirt in water, and that cleaning of wash, that is wash our clothes with clean. So you can see that suppose in your NCERT textbook it is given how that oils are removed. See, this is grease and clothes and grease. There is grease. There is our oil, some dirt. Grease or dirt. In how it works means that soaps are that molecules which are two ends. That is, they have a different properties. One is called hydrophilic end. Hydrophilic end. Another one is hydrophobic end. Hydrophilic and hydrophobic. Hydrophobic end. See, this two ends mean the hydrophilic end and hydrophobic end. Usually, the I can explain here. Here, this is the hydrophilic end, and this is the hydrophobic end. In that empty space, that is the darkened one, shadow one is hydrophilic, and this is the hydrophobic. See, the grease and oil when react with the soap, what happens mean slowly, that is pulling out. Pulling out mean so like this. See, molecules like this. See that that interacts with the hydrocarbons when the soap is the surface of water. The hydrophobic, that is tail. The hydrophobic is tail. The hydrophobic tail of a soap will not be soluble in water, and the soap will align along with the surface of water. So with the ionic end of water and the hydrocarbon tail, that pouring of that water, that is the inside of the water. These molecules, so look at this, these molecules have unique orientations that keeps on hydrocarbon portion out of the waters. So thus the cluster of the molecules in which the hydrophobic tails are in the interior of the cluster. Interior of the cluster, this formation is called micelle. So that the soap is formed and micelle is able to center of the micelle. So able to center of the micelle. So like slowly remove it. So like this. So totally the grease are completely removed. So this clothes are very cleanly observed. So this is the interactions of the soap. Okay. The micelles stay in the solution in a colloidal and will not come together to the precipitate because of ion and repulsion will be there. So that the dirt is suspended in the micelles is also easily rinsed away. So that the soap micelles are large enough to scatter light. Hence, a soap solution appears cloudily. Okay. Then see the soap reaction, that is the washing of have you ever observed that is while bathing that that foam is formed with the difficulty and the insoluble substance, that is called scum. The remains after washing with water, what happens? This caused by the reaction of soap with the calcium and the magnesium salt, which cause the hardness of the water. That's mean you suppose use a large amount of soap. What happens? The water will be harder. The problems overcome using the another class of the compounds called a detergent, that as a cleaning agent. So detergents are generally sodium or sodium salts of the sulfonic acid, that are ammonium salts. Sodium detergents are sodium salts of sulfonic acid or ammonium salt. That is ammonium salt with ammonium salt with chloride or bromide. With the chloride or bromides or ions or extra, whatever it is. That means both have a long hydrocarbon chain. The charged end of these compounds do not form the insoluble precipitate with the calcium and magnesium ion in hard water, so that thus they remains effective in hard water. So detergents are usually used to make shampoos and products for cleaning clothes. Okay, student. Thank you.